for it, it'll update. There it is. Go ahead.
We've taken this clean air filter, we've taped off 50% of it. We're going to put it back in the truck and see what kind of horsepower numbers we get on the dyno with it.
Okay. What do you think? Is it going to go up, down, stay the same?
I think it's going to go down a little bit.
Okay. Sounds good. Really?
Alright, to my complete and utter astonishment, we actually got a little bit more horsepower out of the filter being 50%.
Yeah, you have to clarify that. So we had 140 without restriction.
Right.
And then with that restriction halfway, what was it?
143.
Okay, 143. Is 3 horsepower significant?
Not really.
Not really. So it's
not really a change at all.
okay, definitely not a change. Definitely didn't go down, did it?
No.
Okay.
It did not go down.
Like we were thinking, right?
Right.
Okay. So now what do you got there? Show us.
I've added a little more duct tape to the filter. You figure this is about 75% restriction around the sides, the top.
Okay.
We're gonna put this back in, see if it changes at all.
Okay.
Just think by the end of this, you'll be pro at changing the filter.
Yeah. Like I haven't.
Okay, so 75% of that filter taped off. We're not really seeing a reduction in horsepower. Why?
I think at this altitude, as low as the air pressure is at 6,000 feet, that 75% restriction on the intake is just not enough to affect it.
So you think it's elevation or elevation related?
Right.
That could be. That's not a bad idea. I think something like that could be a possibility. What do you think, Pat?
I just think that there's still enough opening in that air filter that it's still getting plenty of air to actually run.
Okay.
I don't think it's restricted enough.
That could be too. The other thing is that chances are the computer is compensating, and so you know there's still enough air to produce the amount of power that this engine needs to produce, and the computer can completely compensate for what's going on so far. So let's go farther with it.
All right. Once again, the numbers didn't change at all, so this time we have narrowed it down to a tiny little strip of airflow for the engine. I think this is finally the point where we're going to start seeing some performance problems.
What do you think, Pat?
I don't know. I don't think it will.
Okay.
I guess we'll find out.
I think we will find out. Okay. So it's starting to show some consistent loss, but not very much.
I think we're just right at the computer's limit for being able to compensate for the reduced airflow.
Okay.
Much more restriction than that, I don't think it's going to be able to keep up.
All right. That's entirely possible. So let's keep going with it, right? Go ahead.
If the computer can compensate for this tiny little amount of airflow, I'm going to be astonished.
Well, here's the thing. The computer can compensate, and it can get the engine, or it can make the engine run at the stoichiometric air-fuel ratio almost regardless of how much airflow you actually have.
Whether or not there's horsepower loss involved.
But it's going to affect horsepower, and I would say here we're going to see more horsepower loss. Now, there's also a possibility that what will happen is the engine might not even be able to run in the test parameters that we have set up. Meaning it'll get to the point where it's not going to be able to run wide open throttle between 80 and 95 miles an hour. And that might happen at this point or not. We will find out.
I'd be shocked if it didn't.
So the computer compensates, but it can't make up for loss of airflow after a certain point. I mean, there's nothing it can do.
I'd say we're reaching that point.
I'd say so too. Okay, you're starting to lose horsepower now.
Significantly.
Yeah, and it's becoming very definite now.
We've gone past the point where the computer can effectively compensate. Now we're just dropping horsepower.
Well, I'm sure that the emissions are probably still okay because the computer is definitely compensating for that, but it can't make up for the loss of airflow now, and so power is definitely declining. Go some more. Okay, that's all we got left.
Yeah, this is... At some point, we're going to reach the point of no return here. The truck just will not run at open throttle. So, I don't wonder if this is it.
Well, it's going to run. But the thing that's interesting is we've been running this test on, between 80 and 95 miles an hour. And perhaps it would have been better to run it with RPM limits, because you can always force an engine to, well, not always, but I mean, it may eventually get to the point where it'll run to the RPMs, but it won't run to that speed. So far, that hasn't happened. So we've got this filter pretty well plugged off. We are starting to see some significant loss in power because we're down 20 horsepower from no blockage. So what's it going to do this time?
I think it might drop a few, but I don't think it's going to drop a
Okay.
whole lot.
Still just going to drop a few still?
I mean, with
Yeah,
that
we're
whole
seeing
air
pretty
filter.
consistent.
Now, the other thing that we've started to discuss, the other thing that we've been thinking about here is the notion that we are most likely sucking air in from all sorts of other places. Okay,
Right.
there's no air intake system that's completely airtight, and so we're probably doing that at some point, and we may get to the point where we have this completely blocked off, and it just isn't going to run at all. Or I should say, it's running, but it's sucking air from everywhere else except through the air filter. But let's do one more like this before we go off, plug it off completely. It didn't want to accelerate, did it?
It didn't want to go at all.
Didn't want to go at all. So let's see what our numbers come back with, because it was struggling mightily. Okay, now we've got some very significant power loss.
64 horsepower.
Okay, so it dropped all the way to 64.
Yeah, there's no way the computer can handle that much.
Well, there's just way too much air loss. So the amount of fuel we're mixing, we just can't get to keep it stoichiometric. We can't produce much power. But the thing that's interesting is how much restriction did we have to apply to that filter?
Like 95%?
Yeah, like a lot. Like it's very, very restricted.
We've got maybe a couple square inches of space on it.
Yeah. So what does this tell you about? What does this tell you about, you know, like obviously air filter maintenance is important, but when you see those commercials for auto parts stores and other places saying, oh, you got to change your air filter, you know, or you're going to suffer from significant power loss and you're going to have all these problems and your car's not going to run good.
Maybe if you are out in the woods somewhere and you get it caked with mud, but just regular driving, I don't think it's ever going to get dirty enough to cause that kind of a problem.
Okay. Only in extreme situations would you see major power loss, because we started losing 5-10 horsepower here and there when it was pretty well plugged off. Now, obviously that can happen, and I'm sure it does happen on a regular basis to vehicles that are out there on the road. But this just kind of illustrates that, you know, you really have to have some significant blockage before you get to the point where, you know, you have major consequences. Right? Okay, do you think we need to go any further?
I think that this has been pretty conclusive.
Yeah, I think it's pretty conclusive at this point. The next step would be to block off that filter entirely, and I just don't think that there's a reason to do that, because honestly what will happen if you plug it off entirely and try to run it, depending on the air leakage you have around your box and in the other tubes and stuff, you're going to collapse the filter. Basically, you'll just fold the filter in half because the air will try to find a way through. But
Yeah.
it may look like that now. Who knows? Okay, show us what we got.
This is what happens when you have a 95% restriction on your air filter at high load. It doesn't hold up too well.
Look how right here how it pulled that pleat apart, trying to get the air to flow through there to breathe, and then of course when that just wasn't cutting it anymore, then it collapsed the whole entire air filter.
Yeah, this is trashed.
But it's funny how that didn't happen until we got down to just that little teeny bit.
Yeah, you would expect it
happen.
to happen sooner.
Yeah, you would, but no, it didn't.
Pro parts stores.
But this is a good example, you know, and you say, well, what caused that? What was the force that did that? That was atmospheric pressure. That was the 11.7 psi of atmospheric pressure we have here at our high elevation that smashed that filter. It wasn't the suction, it was atmospheric pressure that did that. You know, all we did was create a negative area that was so low that atmospheric pressure was able to smash it like that. So anyway,
Pressure leak was force divided by
so
area.
we learned, did we learn something, boys and girls?
We did.
Yes, we did.
That's good.